Welcome students to Darasa Online. We have a chemistry session. Your teacher is Mr. Kenneth Kaunda. Now in our last session we introduced the topic of chemical bonds, and remember we looked at some of the concepts of chemical bonds. We defined what chemical bond is, and we give examples of situations whereby not necessarily chemicals but outside, like building, where we are talking about bonds. We are in the building blocks, we put some mortar in between the blocks so that the blocks can stick together, and we're calling that bonding of the blocks. Now we brought it back to our chemistry, and we said when atoms combine, then you have to have something in between them so they can be able to form a chemical bond. And we said chemical bonds are formed as a result of sticking or holding atoms together. Now atoms are held together by electrons. So we said in chemical bonding, electrons plays a major role. So in our preview, we said covalent bonds are bonds due to sharing of electrons. Now, sharing of electrons, we conclude and decide to say that they are between non-metallic atoms. Why? Because non-metallic atoms do not have the tendency of losing electrons. They have the tendency of attracting electrons. That's why we said covalent bonding takes place between electronegative atoms, and nonmetals are electronegative. They don't have the tendency to lose, they have the tendency to bring to themselves. And because all of them want electrons, then the two can be able to share. Now, if you leave covalent bonding, today we are going to be looking at electrovalent bonding, which sometimes we call ionic bonding. Welcome. Electrovalent bonding. Now students, if we said covalent bonding is the bond between nonmetals, and it's the bond which is formed as a result of sharing, so electrovalent bonding is simply the opposite of covalent. Now what does the opposite mean? Opposite means electrovalent bonding is the bond formed as a result of transfer. Remember when we were introducing the concept of chemical bonding, we said the reason why atoms bond is to search for stability. Now how is stability attained? It's attained by electronic configuration. That means all the atoms need to have an octet state of configuration. That means the stable noble gas configuration. Now if an atom does not have a configuration like 2 to 8, it has something like 2 to 2, or something like 2 to 7, then this atom and this atom, they are not stable. So for them to be stable, they have to see a way of coming to this kind of configuration. And that one is attained by electron transfer, not now sharing. So in electron bonding, we talk about electron transfer and we don't talk about sharing of electrons. Now, how is electron transferred? A non-metal which is having a configuration of maybe 2 to 1, or 2 to 8 to 1, or 2 to 2, or 2 to 8 to 3, because metals are found in group 1, group 2, and group 3. So if an element group 1, 2, and 3 is supposed to form a bond, then they don't have the tendency to attract electrons, to gain electrons. They have the tendency to release the electrons. It is for them, for example, in this atom 2 to 1, for it to be stable, then it is supposed to either acquire 7 electrons, so that becomes 2 to 8, or lose this 1 electron, so it can become 2. Now, it is easier to lose the 1 electron than to acquire 7 electrons. The same applies to 2 to 8 to 2. It is easier to lose the 2 than to acquire 6. Here, it needs 5 electrons. So it can either gain 5 electrons or lose 3 electrons. It is easier for this atom to lose the 3 electrons than to gain 5 electrons. So we say normally metals form bonds by losing their electrons. It's easier. Although we need a lot of energy to lose the electrons, but it's easier for them to lose electrons than to gain electrons. Remember, when an atom loses an electron, then it undergoes what is called an oxidation reaction. Now, these electrons, when they are lost, then there are some particular atoms somewhere that really needs those electrons. It's a non-metal. Non-metal needs electrons. So if a metal loses the electron, then that electron can be grasped very, very fast with a non-metal. It's something like somebody needs something which I have, and then I throw away that thing. The other person will simply take that thing easily without any struggle. So a non-metal is waiting for this metal to release the electron so that it can acquire. The acquisition of that electron or the attraction of that electron, we call it a reduction process. So it means in the electrovalent bonding, we talk about oxidation, reduction, reaction. So let's see how we can be able to define electrovalent bonding from that preview. So we say most atoms attain stability. That means noble gas electronic configuration by electron transfer. When I talk about transfer, it is either electron gain or electron loss. Electron gain or electron loss. Now, electron bonding is a bonding due to this transfer of electron. i.e. transfer of electrons from the metals to the non-metals. So electrovalent bonding is a bonding between metals and non-metals. Electrovalent bonding is the bonding due to transfer of electrons, and also we can conclude by saying it's a bond between a metals and a non-metal. So we said the metal normally loses electrons, i.e. they undergo oxidation reactions, and the nonmetals gain the electrons, so they undergo reduction reaction. So because this is a chemical reaction process, let's try to see these oxidation reduction reactions in the process of transfer of electrons. From there, now we can be able to understand how these atoms do bond together. Now let's see the oxidation of metals. Let's say we have got a metal M. A metal M wants to lose electrons. Now, if it loses electrons, then it undergoes a process. Remember, the electron to be lost is held by the positive nucleus. We have this kind of thing. This is my metal. It has got an electron in the atom shell. This electron is negatively charged, but the nucleus is positively charged. So there's attraction between the electron and the nucleus. Now, this attraction between the electron and the nucleus, for us to release this electron, the first thing is we have to break this bond, or the force of attraction, so that the electron can go. We need what is called ionization energy. because ionization means an atom is losing an electron to become an ion. Now, this ionization energy, if it is enough, then this electron can go. If it's not enough, the electron will stay. Remember, during our session of covalent bonding, we talked about aluminum chloride. And then we said aluminum has got 3 electrons, which if it were to form an ionic compound or electronic compound, then aluminum is supposed to lose all the 3 electrons in the outermost shell. But we said because the amount of energy required to release all the 3 electrons is too high for aluminum to achieve, then most likely aluminum will form a covalent bond. Why? High ionization energy. Now, if this electron is lost, then we say this metal has been oxidized. But this is a chemical reaction. Let's try to look at the reaction process or the reaction equation for the formation of these ions. So we have a metal M. It is losing electrons, which no matter how many, maybe let's say n electrons in the valence shell. So we have got forming N plus Ne. It means this metal loses n electrons to form this ion. This is what is called an oxidation reaction. So M is an atom, loses electrons, n electrons, to become N plus. Now this is now an ion of M. It means that when atom loses electrons, it becomes an ion. It does not remain an atom again. It becomes an ion. Now this ion, which is positively charged, is the one that will going to bond with the ion of the nonmetal to form a bond, which is called ionic bond. So for example, if you have something like sodium, lose an electron to become sodium ion, or something like calcium also loses 2 electrons to become an ion. Then if you have these ions together, and then also you have got nonmetallic ions, for example a chloride ion, for example oxide ion, then the nonmetallic ions which are negatively charged will bond with the metallic positively charged ions to form what is called electrovalent bonding. Remember, electrovalent bonding is also called ionic bonding. The reduction process, or say the reduction of nonmetals. Let's say I've got a nonmetal X gaining a number of electrons, let's say n electrons, to become an ion with this charge. Number of electrons is n, number of charges is n also charges. Then this one now becomes a negatively charged ion. That means when nonmetals gain electrons, they become negatively charged ions. E.g., we can have chlorine gaining an electron to become a chloride ion, or we can have oxygen gaining 2 electrons to become an oxide ion. Now these negatively charged ions will combine with the positively charged ions to form an ionic bond, or what we call electrovalent bond. So in the formation of the bonds, in the formation of the electrovalent bonds, it is these ions that attract each other to form the bonds. So e.g., we can have, for example, in the formation of, say, sodium chloride, in the formation of sodium chloride, we have got these expressions. We have got sodium, then we have got chlorine giving us a chloride ion. We have got oxidation of sodium and also reduction of chlorine. Now what will happen is that these two, the sodium ion, this one, will combine with the chloride ion. Now, because we have got positive and negative, there's attraction between the positively charged ion and the negatively charged ion. So when they combine together, now they'll form what is called sodium chloride. Now, what can that one tell us about this kind of bond? Attraction of the positive and negative. So we say when the positively charged sodium ion is attracted to the negatively charged chloride ion, then they form an electrovalent bond or ionic bond. So the attraction of the sodium ions and the chloride ions gives us what is called an electrovalent bond in sodium chloride. Now, let's try to define this force of attraction. We talk about positive, negative, attract one another. Let's see how we define it in chemistry. This attraction between the positive and negative ions is called electrostatic. Force of attraction. Electrostatic force of attraction, which is very, very strong. That's why covalent compounds are very, 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 very strong. Now, we have explained the function of this ionic compound, sodium chloride, using oxidation reduction redox process. But still, in general knowledge, we can still have the same kind of reaction in this way. Sodium is 2 to 8 to 1. And also chlorine is 2 to 8 to 7. Sodium has to lose this one electron, and then chlorine has to gain the electron. So what is going to happen? Sodium will lose this electron, and the electron will be taken by chlorine. So that chlorine becomes 2 to 8 to 8, sodium becomes 2 to 8. In both cases now, both the sodium and the chlorine will be enjoying octet state of stability. So let's see. We have got this. And then we have this. We have got sodium 2 to 8 to 1, chlorine 2 to 8 to 7. Now, we use this example of chlorine when we look at covalent bonding, and we say if it were covalent bonding, then this electron and this electron will be shared. But now, in this case, it is transfer of electron. That means this electron of sodium will be transferred here to chlorine, so that it becomes 2 to 8 and also 2 to 8 to 8. So we have, this one now becomes now, because it has, the electron is lost, it's now not an atom. It becomes what is called an ion, positively charged, because it has lost one electron. Now this is 2 to 8, which is sodium ion. And this one gains the electron, so it becomes I've written this electron as X to represent it came from sodium, it has gone to chlorine. But now you can also see that chlorine is now having 2 to 8 to 8. Now this one is now not an atom, but it's what's called an ion, which is 2 to 8 to 8, which is a chloride ion. Now these two will attract one another because positive charge, negative charge will attract each other. So the whole of this compound now is what is called sodium chloride. So you can draw our sodium chloride like this. Now if the positive and negative now attract one another, then we'll form this kind of compound. This one now is what is called sodium chloride. Attraction between the positive and the negative. And this bond between the two, this attraction is too powerful and too strong, is what is called electrostatic force of attraction. Let's see example of, let's say, calcium oxide. So we have calcium, which is 2 to 8 to 8 to 2. Then you have got oxygen, which is 2 to 6. 2 to 6. So if you are to do this kind of setup in ionic compound, then calcium will lose these 2 electrons because oxygen requires 2 electrons to become 2 to 8, which is octet state. Now for calcium to attain octet state, instead of gaining 6 electrons, it will lose these 2 electrons, and the 2 electrons will be grasped by oxygen. So let's draw its structure. After losing the 2 electrons, it becomes and now it's not an atom, now it is an ion. It has lost 2 electrons, so it is 2 positive. This one is 2 to 6. It gains 2 electrons and then becomes 2 to 8. Now it has also become an ion. And now the attraction between the 2 positive charge and 2 negative charge now is what is called electrostatic force of attraction, and now that one also gives us what is called calcium oxide, which is ionic compound. We can also use the idea of redox to write its equations. So we have calcium loses 2 electrons to become calcium ion, and also oxygen gains 2 electrons to become oxide ion, and now the calcium ions combines the oxide ions to give us what is called calcium oxide, and then you have got its open structure that way. Let's look at another example. Let's say we have magnesium fluoride. Magnesium fluoride. This is ionic compound. Magnesium is 2 to 8 to 2. Fluorine is 2 to 7. So what's going to happen? Fluorine needs only 1 electron to become stable, but magnesium needs to lose 2 electrons. Now, if magnesium loses 2 electrons from here, and there's only 1 fluorine, it means that fluorine get 1 electron, and the other electron will be floating. So what's going to happen is that we will have to have 2 fluorines, so that each fluorine will acquire an electron. So the formula of magnesium fluoride is 2 there. So that for every 1 magnesium losing 2 electrons, then each fluorine will acquire 1 electron to become stable. So we'll have 2 of these ones. So that 1 electron will go there, and then another electron will go there. So at the end of the day, it will be 2 to 8, 2 to 8, and 2 to 8, and all of them will be enjoying stability. So we have magnesium losing 2 electrons to become magnesium ion, and also 2 of the fluorines will be gaining 2 electrons to become 2 of fluoride ions. So you have got 2 fluoride ions and also 1 magnesium. So that Mg2 plus 2 F minus will give me MgF2, and this is our redox equation. Let's draw the diagram. And then fluorine, fluorine is 2, magnesium is 2 to 8 to 2, fluorine is 2 to 7. Then magnesium will have to lose the 2 electrons to become magnesium ion. So we'll have now this one is 2 positive. Now it is 2 to 8, which is Mg2 plus. Then we'll have 2 of the fluoride ions. So we'll have this one and this one. Now these ones are 2 of fluorines, which now 2 to 8. There are 2 of them. Now this one here now is what is called magnesium fluoride. 1 magnesium with 2 fluorines. So there's attraction between these charges. There are 2 charges here. Now if you combine these 2 also, we'll have 2 charges. So there's that mutual agreement between the positive and the negative. That one becomes our magnesium fluoride. We can have another example. Let's say we have sodium oxide. Sodium oxide, where we have got this sodium is a metal and oxygen is a non-metal. Oxygen will give 2 electrons to sodium, so that both sodium and oxygen will become stable. We can have a structure, then we're able to illustrate. So sodium, we have (2 to 8 to 1), and oxygen will have (2 to 6). Now if oxygen requires 2 electrons and sodium can only produce 1, then it means that if this sodium loses this 1 electron and gives it to this oxygen, then oxygen will still require an electron. What that means, students, is that we must have 2 sodium atoms to combine with 1 oxygen atom, just like you can see in the formula. 2 sodium atoms for every oxygen. So we'll have this sodium losing an electron to become (2 to 8), and this one becomes (2-). So we have got 2 sodium ions, 2 to 8, 2 to 8, combining with 1 oxygen ion. Now the whole of this one now is what is called sodium oxide. 1 oxide ion combining with 2 sodium ions, we get sodium oxide. Now we can be able to illustrate this kind of scenario using our redox equations. So we have 2 sodium atoms losing 2 electrons to give us 2 sodium ions. At the same time, 1 oxygen atom acquires 2 electrons to give us an oxide ion. Then now we have the equation of 2 sodium ions combined with 1 oxide ion to give us sodium oxide. Now this is our ionic compound of sodium oxide. Now we can be able to use a number of examples to illustrate these kinds of electrovalent bond formations. But now let's stop there and look at some of the properties of electrovalent compounds. Properties of electrovalent compounds. Now students, let's try to just see normally. A good example of an electrovalent compound is sodium chloride, the one you're using at home, which you call the common salt. Now let me ask you a question. If you take common salt and dissolve in water, it will dissolve. Now we are supposed to know the reason why it's dissolving. At the same time, if you take sodium chloride, the common salt at home, put it in a pan, and then try to heat that pan, will you see the salt melting or not? I don't think it's going to melt. That also gives us a good property of the electrovalent compound. So let's try to review some of these properties and see the reasons why they behave like they do. So the first property is most of the electrovalent compounds are crystalline solids. E.g., you can have sodium chloride. It's a crystal. Why is it crystalline? Because the sodium ions and the chloride ions are joined together by strong electrostatic force of attraction to give it that kind of structure. So it's because of the attraction between the ions. So we have the reason we say is due to the strong electrostatic forces of attraction between the ions. The second one is electrovalent compounds are soluble in water. The reason is water is a polar solvent. Now the rule of dissolution or solubility is that polar dissolves polar, or like dissolves like. Now if sodium chloride is a polar solute or a polar substance, it means that it can only dissolve in a polar solvent, for example water. It means that if you take sodium chloride and put it in something like a non-polar solvent like benzene, ether or alcohol, it will not dissolve. So it dissolves in water because they are polar in nature. So these compounds are polar in nature. We have polar solvents like water only dissolves polar solute. The third one, we say electrovalent compounds have high melting and boiling points. High melting and boiling points. Now when you associate high melting and boiling points with electrovalent compounds, what you're trying to say is that when you have that crystal structure of an ionic compound, then you cannot be able to melt it. Or if you are to melt it, then you need a lot of heat energy. Why? These particular ions are joined by strong force of attraction. Let's say we have got sodium and chloride ions. Now this is positive and negative. The force joining the positive and negative components together is a strong electrostatic force. For us to now disintegrate it into ions themselves, then we need to have a lot of energy to break this bond. This energy is so high. That's why they have got high melting and boiling points. That's why I said in my first expression, can you melt sodium chloride at home? You cannot melt it. So it is due to strong electrostatic force of attraction, which requires high amount of heat energy to disintegrate the compound into its ions. The fourth one is that they are good conductors of electricity. Now they are good conductors of electricity. We said conduction of electricity is as a result of presence of ions. Remember, current can only be transported from one point to the other using ions. Now, because these components are made up of ions, then we expect that they can be able to conduct electricity. The question now is, in which way or in which form will they conduct electricity? In solid form, they cannot. It's just like if you pass current through a solid compound, like ionic compound, it won't conduct electricity because there are no ions. But when the compound is integrated into its ions, then it can be able to conduct electricity. How do we do it? Maybe by dissolving the substance in water, it will form ions, or by melting the substance, then it also form ions that can be able to conduct electricity. So ionic compounds conduct electricity because of the presence of ions when it is molten state or when it is in aqueous solution. So they form ions in aqueous state or when in molten state. These ions are the ones conducting electricity. Now in this part, when we talk about solubility, we say they are soluble in polar solvents like water. But we mentioned that they are not soluble in non-polar solvents. Maybe you can put a note that soluble in water but insoluble in organic or non-polar solvents. A good example of a non-polar solvent or organic solvent is ether, benzene, even alcohol or ethanol, e.g. ether or benzene. So they cannot dissolve in ether and they cannot also dissolve in benzene. These are a few properties of electrovalent compounds. I do believe in your study, as you study, you can even get some points which are not here. If you get those points, then just try to add them on the points that you have already, and then you are good to go. Welcome students again. The session is still on. We discussed electrolytic bonding. We took a short break and I'm back. And before I left, I said when I come back, we'll look at some of the questions that you'll meet in your daily studies. Now let's see our first question. Our first question is saying an element M in group 2 combines with an element N in group 6 to form a compound X. Briefly explain the following. Remember, group 2 elements are metals, group 6 elements are nonmetals. So this is a bond between metals and nonmetals, which is electrovalent bonding. Now explain the following: the structure of X, solubility of X in water, and electrical conductivity of X. Remember, this kind of properties, we said, it's not just a must to know why, not just a must to know that it is soluble in water or it can conduct. Remember, we said you must give us a reason. So if you sort of explain, means you give a reason. So why do you think X is soluble in water? Why do you think X can conduct electricity? This is an ionic compound. We have group 2 and group 6. When they combine together, they'll form, let's say, M2 plus and N2 minus, group 6, group 2. So we'll have Mn, which is ionic in nature. So the structure, the question asks us the structure of X. Is it solid? Is it liquid? Is it gas? We learned that electrovalent compounds or ionic compounds mostly are solids in nature. They are solid crystals due to high attraction between the ions. Solubility, all ionic compounds are soluble in water. Why? Because they are polar in nature. And also in terms of electrical conductivity, we say X can conduct electricity either in molten state or in aqueous solution. Why? Because they can form ions in solution or in molten state. Question 2 is saying, briefly describe the term redox reaction with reference to formation of sodium chloride. Redox reaction is a reaction where oxidation and reduction takes place at the same time. Redox reaction is a reaction in which oxidation and reduction processes takes place at the same time. So if we say we apply redox reaction in form of formation of sodium chloride, what the question is asking us to do is to write the equations for the formation of sodium chloride. Remember, I think we did that example. We said sodium loses an electron to become an ion. And also chlorine gains an electron to become a chloride ion. And then we said now the sodium ion combines the chloride ion, and there's mutual attraction between this electrostatic attraction between sodium ion and chloride ion to give us sodium chloride. So because this is oxidation and this is reduction, then the process of formation of sodium chloride is a redox process, and that is our solution. Question 3 is saying covalent compounds are generally insoluble in water and non-conductors of electricity. Despite the fact that HCl is a covalent compound, it conducts electricity. Briefly explained. The question is trying to take us back in what we learned in covalent bonding and then brings us back again to electrolytic, because conduction of electricity is electrovalent bonding. Non-conduction is covalent. So we have to mix these two things. Remember, we discussed about HCl, and we said HCl is covalent because of sharing of electrons. At the same time, we said HCl can form an ionic compound due to partial charges on hydrogen and chloride. Why? Because we said chlorine is highly electronegative. So when it is highly electronegative, it is capable of withdrawing electrons from the outermost shell of hydrogen. So the hydrogen, the one electron of hydrogen can be released because of the attraction power of chlorine. Now if it's released, then the hydrogen will form a partial positive charge and chlorine will form a partial negative charge. Now the partial positive charge, negative charge will attract each other to give us some kind of ionic character in HCl. This is what we mean. We mean HCl, this has got an electron. This electron, because of the strength of chlorine, can be pulled away from the hydrogen, so that the hydrogen loses the electron to chlorine. Then the hydrogen now will have a partial positive charge, and the chlorine, which will gain that electron, will have a partial negative charge. Now because there is positive and negative, they'll form what is called ionic bond. Now ionic character means they now will conduct electricity, because now HCl will now dissociate to give us hydrogen ions and chloride ions. Now these ions now are the ones which are conducting electricity. So HCl can be covalent, at the same time can be electrovalent in one way or the other. Question number 4. Sodium atom reacts with chlorine atom to form sodium chloride as shown in the following figure. Describe this reaction in terms of electrons. We have got the structure of sodium, and they have drawn only the outermost shell. 1 electron in the outermost shell of sodium and 7 electrons in the outermost shell of chlorine. In this case, sodium has lost an electron to become positive charge, and also chlorine has gained that electron from sodium to become a chloride ion. The attraction between the positive and negative now gives us the sodium chloride. I think this one is simple because we discussed it in our discussions. Question number 5. Under what conditions does sodium chloride conduct electricity? One of the properties of ionic compounds is that they conduct electricity. The question asks us, in what condition can sodium chloride conduct electricity? Now, we said there are only 2 conditions where ionic compounds can conduct current. That is when it is molten, because it will form ions when it is molten. At the same time, can conduct electricity when it is in aqueous solution. That means you can put sodium chloride in water, you stir, and then it forms a solution. Inside that solution, we now have sodium chloride ions. The presence of the ions in molten or aqueous states gives it that property of conduction of electricity. We are talking about sodium chloride solid. If you heat it, you get sodium ions plus chloride ions. Or sodium chloride solid, if you add water, then we have sodium ions and chloride ions. The presence of these ions are the ones that are doing the conduction of electricity. So it's supposed to be in molten state or in aqueous solution. Question 6. Sodium reacts with oxygen to form sodium oxide. Explain the oxidation and reduction reactions that took place. I think this question also we handled it last time. Just write the equation of reactions between sodium and oxygen in terms of redox, and then you are good to go. Now, because of time, we are coming to the end of the session, but you have got some reference books which through your studies, your private studies and etc., you can be able to have some questions. I do believe after every end of a subtopic or a topic, there are questions for you to do. Try to go to these books, or not this one, that ones you have. If you go to the subtopic of electronic bonding, try to check the questions and see how much you can be able to do. I do believe after this discussion until now, I don't think there's a question that can be so hard for you to handle in electrovalent bonding. I wish you all the best in private studies. Even as you look forward to your exams, I wish you all the best. Thank you. I'm Teacher Kenneth Kaunda. I was happy to be with you today.